So next up, for our second last talk for the afternoon, the technical lead seismologist from WRA, Huaiyu Yuan, will take us through progress towards phase 3 release and, acquisition, processing, release of phase 3. So take it away.
Thanks, Chops, and big thanks to everyone for holding all the way to the second last one. And especially I'll have to thank the previous colleagues for setting up the WRA. So we're now in phase 3 already. We have to thank the traditional owners for taking care of the land of WA, especially now WRA is like setting foot every 40 kilometers across the whole state. So what do we do? So WRA simply just maps the lithosphere of WA. And why are we doing it? And again, I have to thank all the previous speakers for setting this up. So WA's lithosphere is like a geological archive, which recorded billions years of tectonic history. And mapping the lithosphere architecture will help us backtrace all these tectonic events and to better understand the mineral genesis behind all these world-class deposits. And I guess we're especially interested in these light blue Phanerozoic areas, and we'd like to see what's going on there in the lithosphere. And lastly, I guess understanding the lithosphere will also help us understand why WA is has one of the most intense seismic zones in Australia. So this is how we are doing it. So this is roughly near the beginning of 2022. We submitted this proposal, so in which we wanted to cover the whole WA, the state of WA, with roughly 1,600 seismic stations. And with each one is like a broadband 127 sensors. The 40-kilometer spacing will enable us to have a seamless Moho across the state. But because of the limited resources, we have to divide WA into 9 different phases, like these 9 regions. And each one has roughly 165 seismic stations. And this will go on for a year, so adding everything together, that's 10 years to cover the whole state. And towards the middle of the year in 2022, the proposal was funded, and I guess we put the first station down in like October or something in that year. So that's in 2022. Through the years, WRA has been progressing. Like we have successfully finished 3 phases of deployment, not the third one yet, but phase 1, surrounding Perth, phase 2, Geraldton, Leonora, all the way to Esperance, and the teams just finished the first download for phase 3. So I guess 3 years on, we're still sort of like a preschooler, but we're quite proud that we have taken a big bite of WA. So WRA is already one of the few very dense regional networks in the world. To further distinguish ourselves, we designed this so-called supersite or multi-parameter acquisition approach. So basically, we do the broadband seismic stations at each point, and that targets the lithospheric structure. And at each site, we also deploy this so-called site characterization approach. So that's a set of very high frequency passive source stations to get near surface structures. Like this will be very good for seismic hazard analysis, and it has an implication to the industry like the bedrock or the cover thickness. We've seen this a couple times. So at each point, we'll have like 2 bags of dirt. And in the end, about 3,000 bags. We'll need to hand them over to the other teams. And the most, I guess, another very important component is this so-called magnetotellurics, or MT. So MT targets the lithospheric resistivity. Before WRA, the community actually had deployments, like campaigns of like these black dots across the state at very sparse locations. And the MT component started late in phase 1, but in phase 2, it caught up with the seismic. And in phase 3, you can see it's at its full speed already. Next year, when phase 3 is finished, they're going to backfill the phase 1 gaps here. So WRA will produce several models or products through the years. Like each year, first is the data. So we have about several terabytes data, raw waveforms that will be published every year. So actually the first one is already published. The second year's will be next March. These are like terabytes of waveforms. And a lot of effort has been made in-house and with the external collaborators to develop this so-called multi-scale lithospheric models. So basically we want to map all the way from the surface. We do the crust, we map the lithosphere, we map the base of the lithosphere. So I'll come back to this later. And then these different scale models will be compiled into 3D data compilations and to make georeferenced images, and these will be accessible through MAGIX. And for each phase, we will have a report. And we also try to get more like publications, like peer-reviewed publications, like this one here. This is for phase 1. So far, we have been collecting contributions, like different papers. And we also have established some sort of platform, so the outside people can use this and can use the WRA data to publish papers. So that's why we can make the best out of WRA. So this is about different scale models. The models actually, we have shown them last year at Open Day, and these are officially published already March this year. So if you are interested, just go for the report. And here I'll just go quickly at several interesting ones. So all the way from the beginning, from the very surface, so this is so-called site characterization method. It generates high frequency data sets, and using that, we can actually have the near surface velocities or the interfaces. You have to ask my colleague, Reza, who's sitting somewhere in the audience, for what these means. But to me, if you look at the so-called geological bedrock, you can treat this like the thickness of the cover, and you can actually see where you have thick cover, that correlates with the Perth Basin and these paleo lake, paleo river, or paleo channels in the map. So moving down into the whole crust, we have crustal shear wave velocities at different depths, and we have, this is the average crustal thickness and the VPS ratio or the composition. You have seen this. I guess the point is, at the crustal level, these seismic structures have these sort of northeast-southwest trends, which is like at high angle to the surface structural trends. So this is in the crust. And moving down into the lithosphere, this is 150 kilometer depth. This is shear wave velocities from surface wave. This is at 100 kilometer depth. This is P wave, this is body weight tomography here. And this is the lithosphere thickness derived from these models. I guess you see the structural trend has changed to north-south. And interestingly, I guess these are the gold deposits. Where you see large lateral gradients, maybe that's where you find gold at surface. So the official release of phase 2 models will be next March, and I'll encourage you all go to Kalgoorlie for this. Here I'm just quickly showing some models we're working on. So this is expanded crustal thickness and VPS ratio maps for phase 1, that's the dashed region here, and phase 2 also included previous temporary arrays. So this is another feature we can include is so-called Moho amplitude. So basically the colors here, blue means it's thick, or it's mafic, or here it's sharp Moho. Sharp Moho means, okay, usually we see that in cratonic or undisturbed archean crust, like the Moho transition is very large. And diffused Moho is usually in the origins, in the suture zones, where the crust has been reworked. Just keep this in mind. So back to the maps. I guess there are a lot of structures to discuss, but here let's just focus inside the Yilgarn. The northern Yilgarn, northern central Yilgarn, or UME, has a very thin crust, and its composition is mostly felsic, and you can see a big, very sharp Moho to the north here, surrounded by something. And the eastern goldfields is relatively thick, but it's still felsic, and the sharpness, I guess, is bimodal. The next one, the southern Yilgarn, is the thickest. Actually, the thickest is over 50 kilometers here, and its composition is more like intergradient to mafic. And interestingly, you can see it's very diffused Moho. Now, if I plot the gold deposits, these white dots on top, it seems gold doesn't care whether the crust is thin or thick or thin. It doesn't really matter. But here, if you look at the VPS ratios, it looks like most of the gold distributions here, they like the mafic, felsic crust. Going into the sharpness, this part, yes, is very sharp, gold. And here in the eastern goldfields, again, this is bimodal. So we don't know what's going on for sharp Moho and diffuse Moho. They all have gold. And quickly, I'm showing some models along the southwest active source line. So basically, this is west, that's east, active source line. These, again, are already published. These are crustal models showing the velocity gradient, like the Moho along the line. This is showing the velocity variations along the line. I guess the point is, along this part, along the line, in this part of the Yilgarn, the crust is really like not uniform. You see lots of different domains or truncations along the Moho. Sometimes these can be mapped to the surface fault zones. Sometimes probably don't. This is new. This is from the site characterization. Look at, this is just 1 kilometers. This shows the shear wave velocities along the line. We see the Perth Basin, we see the paleo channels. The southwest is very fast at the top 1 kilometer. Going down into the lithosphere, now we're looking at 120 kilometers. So this is how the lithosphere here look like. It's like a Boudinage style, different domains. And then you have these different weak zones. It's quite interesting. So this one is, this is resistivity. This is the MT model showing blue is resistive, red is conductive. If you look closely, you may find correlations between the velocity weak zones and conductive regions in this part of the Yilgarn lithosphere. So this trend is actually quite interesting. What you see here, these two at depth, is 85, 150. These are resistivity maps. So there's two different trends going north, south, beneath the Moho. But if you go up into the crust, you see these conductive zones actually change their trend to, differently. This is the plan for next year, quite busy. We're wrapping up phase 3. Well, first we publish phase 2 models and data. We wrap up phase 3, and we will put phase 4 in the field. That's all I have. Thank you.